Lesson 3.3 is about operations with functions. So we've talked about this a little bit already in 3.1. We're also going to use inverse functions continuing on as we go through the lessons, but for today we're going to look at how to compose a function with another function, how to perform the basic operations with functions, and so let's get right into talking about an example. So in these types of problems, they're going to give us two functions. If you look here, we have an f function and we have a g function. So we're going to know which function to use based on the problem. So if we look at problem A, example A, it says to take the f function and add the g function. So that's exactly what we're going to do. The way I like to start this is to take my f function, which is 3 square root of x minus 2. So this I know is the f function. And then it says we're going to add the g function. And my g function is x squared plus 5. So this is my g function up here. So really, all I have to do now is combine like terms. So if I'm looking at this problem, I can rewrite it and you can see 3 radical x minus 2 plus x squared plus 5. So if we look, there's nothing that can combine with 3 radical x. We haven't seen that before, but that doesn't necessarily matter. 3 radical x goes down by itself. I have an x squared. There's nothing that combines with x squared. I can combine this negative 2 with the 5 to make a positive 3. And because I'm done simplifying the problem, I'm going to put the label on the front, which was just f plus g of x. That's how we would say that, f plus g of x. And this would be my final answer. All I had to do was combine my like terms. Okay, so we're going to do the exact same thing over on example B. F minus the g function. So I start with the f function, which is 3 radical x and minus 2. And then I'm going to subtract the g function, x squared plus 5. And you don't have to label f and g like I did, you can just leave it like this. But something to note with subtraction is that I am subtracting this entire g function, which means I'm going to have to distribute my subtraction sign. So whenever you have a subtraction problem, this is the one tricky thing, when you have a subtraction problem, you're going to have to remember to distribute your negative sign. So if I rewrite this, I have 3 radical x minus 2 minus x squared minus 5. Now we're going to combine like terms. There's nothing that goes with 3 radical x. There's nothing that goes with negative x squared. But I can combine the the negative 2 and the negative 5. Negative 2 and negative 5 make negative 7. We're going to put our label on at the end, f minus g of x. And this is my final answer. So we're just following the directions of whatever it tells me. Add the functions, subtract the functions. We have to do it in the order that they give. So in example A and B, they gave me f function first and then the g function, so you have to stay in that order. So let's look at example 3. Or C, rather. My apologies. So example C says find the following operations using this f of x function, x plus 1, and g of x function, where g of x equals x minus 3. So if we look at option or example C, it says f times the g function. So we're going to start with our f function, which is x plus 1, and we're going to multiply times the g function, which is x minus 3. Now we're going to multiply like normal. You know how to multiply this, whether it be with the box or FOIL method or distributive property, whichever one you would like to use. Go ahead and multiply those two binomials together. So we should be getting x squared minus 3x plus x minus 3. X squared minus 2x minus 3 is our final answer. Can't combine anymore, so we're going to put f times g of x. This is our label. This is our answer. Let's look at example D. Now if we look at example D, it says first take the g function and divide by the f function. So we're going to do a division problem, but then if you notice, the part that's new in this example is that there's a number in place of the x. What that number means is that once you figure out g divided by f, once you simplify that, then you're going to plug an 11 in for each of the x values, and then you will evaluate that number. So let's look at g function. So it says take your g function, so we have x minus 3, divide by your f function, x plus 1. Now when this is a division problem, there's nothing else I can do to simplify. We talked about the other day when we were doing Accuplacer review that we can't just cancel out x over x because the x goes with the 1 and the x on top goes with the negative 3, so we can't just cancel out x over x. Some of you will still try to do that in your homework, but again, you cannot cancel x over x because they are not standing alone. So instead, this is all the way simplified, and you'll have a few in your homework where you do a division problem and that's all you can do. Just set it up and that's finished. Okay? So we would be finished except for the fact that this problem says, now evaluate this function at 11, when x is 11. So we're going to plug an 11 in for x up in the numerator and 11 in for x in the denominator. So I should have 11 minus 3 over 11 plus 1. 11 minus 3 is 8. 11 plus 1 is 12. Always reduce in Algebra 2. So if I divide both of those by 4, I get 2 over 3. The last step is to put the label. So g divided by f of 11, that's how we say this, is equal to 2/3. This would be my final answer. Now let's talk about what this means. This means when you take the g function and divide it by an f function, and you evaluate that function for x is 11, your answer should be 2/3. We're going to do a little bit more practice on this. Let's take a look at another example. Let's look at example E. So example E says, take the g function and subtract f, then evaluate it at 2. Remember when we said that we have a subtraction problem, we have to be really careful about distributing that negative sign. So let's set it up first. G minus f So I have x minus 3 minus x plus 1. Now I want you to pause and listen to what I'm about to share. Oftentimes, students want to evaluate the problem at this point, meaning students get it set up and then they know they have to evaluate it for 2, so they're going to plug a 2 in here and plug a 2 in here. Will you get the same answer? Yes. But the problem is this. As the expressions get more difficult with an x squared or a division problem, it becomes more likely for you to make a mistake with a negative sign or make a mistake with a multiplication or something if you don't simplify first. So my word of knowledge and wisdom to you is to simplify the expression first before you ever plug in. And some of you will try to go around that and plug in here. Again, you can start that, but you're bound to make a mistake, and I've seen it time and time again. So I would really advise you to simplify first. So let's go ahead and simplify. X minus 3 minus x minus 1. Remember, we distributed our negative sign here and here. If I combine like terms, I have an x minus an x. Well, x minus x is 0. So in this problem, my variables cancel out, and I have a negative 3 minus 1. Negative 3 minus 1 is negative 4. We always put our label on, g minus f of 2. In this problem, I didn't have a variable left to evaluate at 2. What this means is whatever number you plug in, it doesn't matter because you're not going to have a variable left over to plug in. The answer is going to be negative 4. Now, if you had evaluated it and plugged the 2 in up top, and you plug 2 in here and 2 in here, yes, you would still get negative 4. But again, you're more likely to make a mistake if you have to plug 2 in more areas. Okay, so take a minute to try example F on your own, and we'll see if we get the same answer. Check with your neighbor when you get finished. Okay, so let's take our g function and add that to our f function. 2x minus 2. Now that we have it simplified, now we can plug a 20 in for our x. So you should be getting 38. And remember, we always put the label on. G plus f of 20 equals 38. Okay? Alright, example G. This would be a time when you would say, when are we ever going to use this in real life? Well, here it is. At Best Buy, that should actually probably say Apple. At Apple, production has begun on the iPhone 7. Clearly this story problem has been dated since the iPhone 7 is already out, but anyway. So production has begun on the iPhone 7. The total cost function is given by c of x equals x squared plus 3x, and the total profit function is given by p of x equals negative 2.5 x squared plus 150. X represents the number of boxes of iPhone produced. The total revenue function R of X is such that R of X equals C of X plus P of X. Find R of X. Now, this problem seems a lot harder than what it actually is. The entire problem is asking you to find C of X plus P of X. We have an equation to represent C of X. We have an equation to represent P of X. So all I need to do in order to find R of X is to add C of X plus P of X. Can we do that? Of course we can. So the C of X function is x squared plus 3x. The P of X function is negative 2.5, and we can even put this in parentheses if you want to. 2.5x squared plus 150. We know that this is equal to the R of X function. Now, all we need to do is combine like terms. You would agree that this plus sign right here in the middle isn't going to change the signs of the parentheses. So we can just rewrite this without parentheses if you'd like to. Minus 2.5x squared plus 150. Now all we need to do is combine like terms. 1x squared and a negative 2.5x squared gives me negative 1.5x squared. Plus 3 of x, that doesn't combine with anything. And then plus the 150, that doesn't combine with anything. This is the R of X function. That's all we had to do there. Just had to combine two equations into one. Okay? So the second set of your notes is also the second section of your homework. So please make sure that you look very carefully as you're doing your homework because they are completely different sections where you have to do two different things. So, composing a function inside of another function. So composition of functions, this is where you're going to do something completely different than what we have been doing. And you'll notice this little symbol here. This little symbol means composition. It does not mean multiplication. It means composition. We'll talk about what that means in just a minute. Also, these symbols, or these brackets, also mean composition. So these two things mean the same thing, and you might see them written different, or you might see both of them written in your homework. But it means the same thing. They both mean composition. So what does composition mean? Well, composition means to take the first function that they give you and write the second function inside the first function. It seems a little bit tricky, but it's not, especially if you follow the way that we're working. Let's take a look at this first example. Example A says find f composed with g of x. That just means we're going to leave it in terms of x. So the first thing to do is to look, we have been given two functions, f and g over here. Because they gave me f first in the problem, I'm going to start with the f function. So I'm going to start with f. My f function is x plus 3. So the composition part means wherever you have an x, you're going to take that x out and you're going to replace it with the entire g function. So I write it like this. You don't have to continue to write it like this, but for this example I'd like you to write it like I'm writing. Put a box around the x because that's what we are removing, and we are replacing that x with the entire g function, x squared plus x minus 1. That's what my g function is, x squared plus x minus 1. We still have this plus 3 on the end. Now that I've replaced the entire x function, the entire x in the function, I'm sorry, now I'm going to simplify x squared plus x minus 1 plus 3, and now it becomes a problem like we've been doing before, where we combine our like terms. Nothing can go with the x squared, nothing goes with the x, and then negative 1 plus 3 is a positive 2. So this is the result I get when I compose f with g and leave it in terms of x. This would be my final answer. X squared plus x plus 2 is equal to f of g of x. Alright, so that was one that started off. You start off with whatever whatever function they give you. So they asked us to start with f first, and then we put the g inside of the f. So let's look at example B. Let's take it a little step further. So example B, I'm going to have to keep it here so I can see what the function is. So example B says start with the g of g function and then put f inside of it. But not only are you going to put f inside of it, but once you do that, then you're going to evaluate it for 2. So this is a little bit more complicated, so let's start with the g function first. So I have x squared plus x minus 1. So I have my g function. Then it's saying wherever you have an x, you're going to take the x out and put in the entire f function. So my f function is x plus 3. Now notice, this is still squared, I'm still adding, and I still have my negative 1 down here. So remove the x in my g function, I put the entire f function in for each x. So this should look like x plus 3 squared plus x plus 3 minus 1. Now in the middle, this x plus 3 here in the middle, we don't really need those parentheses. So let's take those off. Alright, before we can combine like terms, let's think about what this means when you square it. X plus 3 squared means what? X plus 3 squared, remember, is x plus 3 times x plus 3. Then I still have the plus x plus 3 minus 1. So why don't you go ahead and take care of the x plus 3 times x plus 3. So you can either box that, or FOIL that, or use a distributive property, whichever one you would like to. So I'll give you a minute to multiply that out. So we should have x squared plus 6x plus 9 plus x plus 3 minus 1. Now we are at the point where we can combine like terms. So x squared stands alone. I have a 6x and an x, which gives me 7x. Then I have 9 minus 1. 9 minus 1 is positive 8. Oops, I forgot that 3. 9 plus 3 is 12. 12 minus 1 is 11. Now this would be finished, except the problem said to evaluate it at 2. So if we're evaluating at 2, that means I'm going to plug a 2 in for each x. I'll do that up here, and you can do it at your seat. So 18 plus 11 is 29. So we'll put our final answer together. G of f of 2 equals 29. That's what we're going for there. If you at this point have any questions, go ahead and talk amongst yourself. There are probably going to be certain people in your classroom who understand and get it and are following. So if you have any questions, please talk and figure it out before we move on. Okay, if there are no questions, let's go on to example 2. This is the same type of concept, okay, except that we have two new functions. We have an h function now and a g function. So it doesn't matter what letters they give you, a, b, c, d, e, f, g, whatever, h of x function, g of x function, z of x function, you can still do the same thing. So this one says find h composed with g of x. So we're going to start with our h function. So I have 3x squared minus x plus 4. Now, this one is a bit long, so just take a deep breath. No groaning. Just take a deep breath. We're not going to do example B, so you can work all the way down the page if you would like to, because this one takes a little bit. So we have our h function, and then it says we want to put g inside of our h. So again, I think sometimes this box is helpful, sometimes it's not, but it gives you a good vision of what you're going to be putting in for something else. Now notice the 3 comes down, it's still squared. The only thing that we're changing is instead of x, we're going to put 2x minus 1. So we have 3 times 2x minus 1 squared minus 2x minus 1 plus 4. So if I wanted to rewrite this without parentheses, or without the box, it would look like this. Now we need to talk about a couple things. First of all, this 2x minus 1 squared means that we need to do the box or FOIL or whatever method you choose to do. So take a minute and do 2x minus 1 squared. So we're getting 4x squared minus 4x plus 1. So I have 3 times 4x squared minus 4x plus 1. Remember, we are subtracting 2x minus 1, so I'm going to need to distribute here and here my negative sign. So I have minus 2x plus 1 now, plus my 4. Please make sure you're following along as I'm working. If you need to pause the video, you're welcome to do that. If you need to rewind and go back, that's fine too. But make sure you're checking with what I have so that you have the same numbers. Now we need to distribute our 3. So I should have 12x squared minus 12x plus 3. And I'm going to bring the rest of the problem down. Now we'll combine like terms. So 12x squared stands alone. I have a negative 12x and a negative 2x. Negative 14x. 3 plus 1 plus 4 is 8. For the sake of this example, let's go ahead and evaluate this at negative 2. So let's do h of g of negative 2 so that we can practice doing that. So we've simplified the problem, and now if I want to do h of g of negative 2, that means I'm going to plug a negative 2 in for each x value. So take a minute and go ahead and do that, and we'll see if we get the same answer. Be careful with your signs. Okay, so 48 plus 28 is 76. And 76 plus 8 is 84. So I should have h of g negative 2 equals 84. This would be my final answer. So this one seemed like a doozy because we had to do some multiplication. We had to do some polynomial multiplication with the box method. And yes, this took quite a few steps. But I want you to pay attention that if you are following the steps, if you are plugging in the correct things and you are not missing anything when you multiply, this should be a pretty regulated process. Okay? So again, help each other out. If you have any questions, work it through with each other. Pay attention during your homework, whether you are composing a function like we just reviewed, or if it's like the first half of the notes where you just have to combine like terms. Okay, so pay attention to that. The directions do change, and make sure that when you see the little open circle, you know that it's a composition. Okay?